Hi there. Here we have a skier at the top of a hill. This hill is sloping at an angle of 30 degrees to the horizontal. And this hill is 100 meters long along the slope. And we need to find out how fast is the skier going at point B as he comes down skiing like this. And I'm also going to share with you an interactive simulation about the same as a small attachment in the description of the video. So I'm going to pause it and I'm going to let you take a dig at this. All right. So if you've had the chance at it, uh, I'm now going to show you my solution and you can compare yours to mine. Now the total distance here is 100 meters. I'm going to denote distance with S. And we need to find the velocity at point B. The velocity at point A is obviously zero because the skier starts at rest. We're going to use the equation, the kinematic equation VB square equals VA square plus 2AS. And we're going to have to find out what the acceleration here is as the skier goes down the slope. Now, let's draw a force balance diagram for the skier. And this, the weight, and this the normal reaction from the slope. And this angle is 30 degrees. And if I draw the components of the weight, what we're going to get is this is 60 and this is 30. So what I'm going to get as the component of weight along this direction is essentially mg times sine 30. Because height upon hypotenuse is sine, and sine 30 is this height upon mg. And hence mg times sine 30 becomes this height, and this height is nothing but the component of weight along the sliding. Mg sine 30, and I'm going to assume there's no friction because skiing is happening on snow. So I'm going to assume a zero friction force. And if that were not the case, I would have to consider normal reaction and the coefficient of friction. But in this case, that's assumed to be zero. And so I have mg sine 30 as the force in the direction of sliding equals m times a, and hence I get a equals g sine 30. And sine 30 being half, this becomes g upon 2. And if I take the value of g to be 10, this is approximately 5 meters a second square. Plugging this value here into this equation, I get VB square equals 0 squared, because VA is 0, plus 2 times acceleration due to all the forces along the incline, and we found that out to be 5 meters a second square, and multiplied by the distance, which is 100 meters. And this is going to give me VB square equals 10 times 100 was 1,000. And that's going to give me VB equals the root of 1,000. And that is approximately 10 times root 10 meters per second. And that's how we can find out how fast the skier is going at point B. Now, if you had to convert this into an exact number, you could substitute for the value of root 10 here and find the exact answer. All right, I'll see you soon. I hope you had fun doing this problem. Bye.